Welcome to Spaceverse, your portal to cosmic adventures. Astronomers have just made a groundbreaking discovery, evidence of a colossal black hole hiding within the large Magellanic Cloud, a dwarf galaxy that has been orbiting the Milky Way for billions of years. But here's where things get even more exciting. This galaxy isn't just a harmless companion. It's actually on a long, slow, yet unstoppable journey toward our own galaxy, setting the stage for a dramatic cosmic collision in the distant future. This revelation not only reshapes our understanding of the large Magellanic Cloud, but also raises fascinating questions about how this hidden giant might impact the Milky Way when the two galaxies eventually merge. In this video, we're going to take a deep dive into the fascinating science behind this groundbreaking discovery. We'll explore how astronomers managed to uncover evidence of this hidden giant, why its existence is so important, and what it means for the future of our galaxy. But that's not all. We'll also take a look at some of the most famous supermassive black holes in the universe, from the monstrous M87 to our very own Sagittarius A, to see how they compare and what they can teach us about this newly detected black hole. Get ready for an exciting journey through the cosmos as we unravel one of the most thrilling space discoveries yet. Spotting a hidden black hole isn't easy. Unlike stars, black holes don't shine. They're the ultimate cosmic ninjas, completely invisible. So how do scientists find them? By observing how their immense gravity affects nearby stars and gas clouds. For this discovery, researchers used a clever trick, tracking hypervelocity stars, rare high-speed stars that don't just zoom through space for no reason. Many of them have been flung away by an unseen giant, like a black hole, using a process called the Hill's mechanism. Here's how it works. Imagine a pair of stars orbiting each other. If they wander too close to a supermassive black hole, its powerful gravity can rip them apart, capturing one star while launching the other out into space at mind-blowing speeds. It's a cosmic slingshot in action. So, what does this mean for the future of our galaxy? Stick around as we unravel the mysteries of this newfound black hole and its long-term impacts on the Milky Way. By analyzing data from the Gaia Space Telescope, which has been precisely tracking the movements of billions of stars, scientists made a surprising discovery. 9 hypervelocity stars in the Milky Way appear to have originated from the large Magellanic Cloud. That was a major clue because stars don't usually move that fast unless something incredibly powerful launched them. After crunching the numbers, astronomers identified the likely culprit, a supermassive black hole lurking at the heart of the LMC, estimated to be around 600,000 times the mass of our Sun. This is a game changer. Until now, we weren't certain if the LMC harbored a supermassive black hole, but this finding strongly suggests that it does. That's a big deal because it helps bridge a gap in our understanding of black holes of this size. We already know about stellar mass black holes, those that form from collapsing stars and typically range from a few to a few dozen times the Sun's mass. And then there are the true giants, supermassive black holes with millions or even billions of solar masses, like Sagittarius A in the center of our Milky Way. But black holes in the middle range, like this one in the LMC, are incredibly rare and difficult to detect. If this discovery holds up, it could provide crucial insights into how black holes grow. Do mid-sized black holes like this one steadily feed on gas and stars until they become even larger? Or do they merge with other black holes during galaxy collisions? The large Magellanic Cloud has been orbiting the Milky Way for billions of years, but it's not just a quiet companion, it's actually on a slow collision course with us. Astronomers predict that in about 2.4 billion years, the LMC will crash into our galaxy, dramatically reshaping its structure. But what happens when a galaxy with its own supermassive black hole collides with another galaxy that already has one? When the LMC merges with the Milky Way, its black hole won't just vanish. Instead, gravity will pull it toward the heart of our galaxy, setting it on a long journey towards Sagittarius A, the Milky Way's central supermassive black hole. As these two cosmic giants draw closer, they'll begin orbiting each other, forming a binary black hole system. Over time, they'll spiral inward as gravitational waves, ripples in space-time predicted by Einstein, carry away energy. Eventually, they'll collide in a mind-blowing explosion of energy, sending out some of the most powerful gravitational waves the universe has ever seen. We've already detected smaller black hole mergers with observatories like LIGO and Virgo, but witnessing such an event with supermassive black holes inside our own galaxy would be a once-in-a-lifetime spectacle. And that's not the only impacts. The LMC is bringing along massive amounts of stars and gas, and when it finally merges with the Milky Way, it could trigger a new era of star formation, lighting up the galaxy in ways we've never seen before. Some scientists even suggest that this collision could reshape the Milky Way, possibly transforming it from a spiral into a more elliptical galaxy. While this event is still billions of years away, studying it gives us valuable insights into how galaxies change over time. Mergers like this aren't unusual. Many of the galaxies we see today are the result of past collisions. And this isn't the only major crash in our future. In about 4.5 billion years, the Milky Way is expected to collide with the even larger Andromeda Galaxy. The upcoming merger with the LMC will serve as a small-scale preview of the epic cosmic showdown to come. To better understand this newly discovered black hole in the LMC, it helps to look at other famous supermassive black holes across the universe. These extreme objects offer clues about how black holes form, grow, and shape their galaxies. One of the most well-known examples is Sagittarius A, the supermassive black hole at the heart of our own Milky Way. We know it's there because of its powerful gravitational influence on nearby stars, which whip around it at astonishing speeds. In 2022, the Event Horizon Telescope captured the first ever image of Sagittarius A, confirming its existence and giving us a new way to study these enigmatic objects. Another legendary black hole is M87, the behemoth at the center of the massive elliptical galaxy Messier 87. This cosmic giant is 6.5 billion times the mass of our Sun. In 2019, it made history as the first black hole ever images, revealing a glowing ring of light encircling its dark core. Then there's TON 618, an absolute cosmic heavyweight, one of the largest black holes ever discovered, with a staggering mass of over 40 billion suns. It resides in a quasar, an incredibly bright and active galaxy, where it constantly devours surrounding gas, unleashing powerful jets of energy into space. So, what do these black holes teach us? They reveal that black holes aren't static. They grow over time, either by consuming matter or merging with other black holes. If the large Magellanic Cloud's black hole eventually merges with Sagittarius A, it could trigger a new phase of growth, possibly turning it into a monster rivaling M87 over billions of years. And that's it. Thanks for joining this journey through the cosmos. If you love this video of Spaceverse, be sure to like, subscribe, and hit that notification bell for more incredible discoveries. Until next time, keep looking up.